Good morning, chemistry students. All right, here we go today. We're going to be jumping into our next chapter. And before we do that, we're just going to kind of do a refresher. Students can write ionic compounds when we are doing the ionic compound chapter. Students can write and identify covalent compounds when we're doing the covalent compound chapter. But when we move to this new chapter and you have to put the two together, students kind of get confused, right? And all of a sudden, everything they knew how to do, they're like, I don't know how to do this. You do know how to do it. And so today we're just going to kind of go over some keys to help you identify when do you do ionics and when do you do covalence. All right, so we can call this in our notes today, ionics versus covalence. All right, today is, oh my gosh, it's already halfway through May. All right, so I think if I were teaching this to you in class, we would just kind of start doing some examples. So that's what we're going to do. All right, when you see, all right, so kind of like maybe the first case is when you see eights or ites. It's always ionic. It's always ionic, and you're going to use canceling and crisscrossing. So, for example, if you come across something and it says lithium nitrate, first thing I notice is there are no prefixes. And no prefixes is always going to indicate that it's ionic. The other reason you know it's ionic is it ends in ate. So when you go ahead and when you do this, you're like, okay, lithium is in group 1. Nitrate 8 is a polyatomic. You'll have to go back to that chart. And my charges are the same, so I cancel. All right, so that was the first key, is that I saw 8. All right. The next thing that you would need to look at is if there are no prefixes. No prefixes always equal ionics. So if there's no mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca, all right, it's going to be ionic. All right, so let's try an example with that. So maybe you see magnesium phosphide. Okay, so magnesium phosphide. There's no prefix here and there's no prefix there. So therefore, you know that it comes from the periodic table. All right, and we have to go back to what does it have? What does it need? Magnesium has 2. Phosphide ends in IDE, so it comes from the table. It needs 3. All right, my charges are not the same, so I crisscross. And I'm left with Mg3P2. All right, so no prefixes are ionics. Next example, if you see Roman numerals, Roman numerals are always ionic. All right, so let's see here. What's an example with a Roman numeral? What if we do copper, Roman numeral 3, chlorate. All right, so copper 3 chlorate. All right, so Roman numerals tell you the charge of the transition metal. So 3 equals 3. Look at the next one. It says chlorate. So it's going to come from that polyatomic chart. So chlorate is ClO3, 1 minus. See if you can write the formula on your own. What do? Do you cancel or do you crisscross? Well, my charges are not the same, so I must crisscross. Polys get parentheses. So this is all things that you have done before, and I would say 95% of you scored really well on the Forbes assessment for ionics. And those of you that didn't just made little tiny mistakes. There's no one that didn't get it. All of you got it. Now you just have to recall how to do it. All right. So far we've covered eights and ites are always ionic. No prefixes are always ionic. Roman numerals are always ionic. If you see parentheses, parentheses are always ionic. Okay, so the last one, you're like, well, when is it covalent? Prefixes are always covalent. Okay, prefixes are always covalent. No crisscross, no parentheses, just straight up symbol, prefix, symbol, prefix. So if you had something like phosphorus, you're like, well, there's not a prefix in that one, but what if it's tribromide? Okay, bam, there's a prefix. So you know that it's covalent. So this one is phosphorus. And how many bromides? Tri is 3. So those are the keys to help you. All right. So let me give you some examples, and then you can go ahead and tell me what they are and what the charge is, or what their symbols are. Okay. All right. So here are 2 examples. What I want you to do, I want you to figure out whether or not it's ionic or covalent. And kind of like off to the side, write the reason why. All right, so maybe after it, tell me, is it ionic or covalent? You can just abbreviate I or C, that's fine with me. And then in the space below, see if you can write the formula. So I want you to pause and copy this down, say whether it's ionic or covalent, and then write the formula. When you're done with that, unpause it, and we'll go through it. Okay, so you should have paused it and done the examples. All right, so the first one we have is dicarbon tetrahydride. Right away, the first thing I read was dicarbon tetrahydride. These are both prefixes. And if we have prefixes, we know that it must be covalent. All right, and so for the formula, I just write the symbol and the prefix. Hydride is hydrogen, and tetras 4. All right, that's covalence. You don't even have to look at the periodic table unless you can't remember their symbols. All right, so in investigating number 2, do I have, I'm going to start from the bottom. Do I have prefixes? No, it's just sodium oxide. Do I have Roman numerals? Nope. So I've eliminated prefixes, so that means that this guy has to be ionic. Right? There are no prefixes, so therefore it has to be ionic. And then I take a look at the ending. I'm like, okay, sodium oxide. It doesn't end in ate. It does not end in ite. I'm looking through that poly chart, and I don't see anything that just says oxide. So therefore, I know that it must just be oxygen from the periodic table. All right, sodium, what does it have? All right, it's in group 1, so it has 1. Oxide is what does it need? All right, well, it's in group 16, so it needs 2. Cancel or crisscross? Crisscross. Na2O. All right, and that's the formula. So you know how to do all of it. Now it's just kind of putting it all together when we mix them all in. All right, I'm going to give you guys 2 more, 2 or maybe 3 more for you to practice with. All right, so now we're back. Sorry, I paused it so I could give you guys some examples. We have 3 more. Pause it. I'm sorry, copy it, pause it, or pause it, copy it. Tell me if it's ionic or covalent. Try to write the formula. All right? All right, so you should have paused it. Here we go. Number 3, did you choose ionic or covalent? Well, we have cobalt. Ding, ding, ding. That is a clue right there. Cobalt 2, carbon 8. All right, we got 2 clues in this one. We have Roman numerals and we have an 8. So therefore, it must be ionic. Formula, cobalt 2, carbon 8 is a polyatomic ion. So therefore, my charges are the same, so I cancel them out. CO3. That's a little o. CO3. Next one, sulfur dioxide. What's your clue? Ding, 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 prefix. All right, so here we go. Prefixes are always covalent, and this is so easy to write. Sulfur is an S, oxide is O, di means 2. There you go. All right, this one down here, number 5, we have ammonium nitrite. Well, some of you might have been hunting for ammonium on the periodic table. Remember, that is the only positive polyatomic. It's a cation. And right here, here's your other clue, ite. Ite is always ionic. Ammonium is NH4, 1 plus. Nitrite is NO2, 1 minus. Ones and ones, cancels or cross? Cancel. So we have NH4, NO3. Good job. We're done. Make sure you do the practice that's on Google Classroom.